Here we have two force vectors, one 25 newtons at a 40-degree angle and another 15 newtons at a 120-degree angle. What do we get if we add these two force vectors? Here's a picture, and this picture is a little bit cluttered up, but let's point out all the features. First of all, in blue here we have the 25 Newton vector at 40 degrees and the 15 Newton vector at 120 degrees. The vectors are drawn to scale. This is 25 newtons and this is 15 newtons, and they appear to be in approximately the right proportion. 15 newtons looks like it's maybe a little too short. Should maybe be a quarter of an inch longer. In any case, this is a reasonable depiction of the two vectors. Now, in order to add these vectors, we want to find the x and y components of the two vectors. Having found the x and the y components, we easily add the vectors by adding the x and components and then adding the y components to get the x and y components of the resultant, just as we did before. So, we start by finding the x and y components. The x component of the first vector, 25 newtons at 40 degrees, the x component will be 25 newtons times the cosine of 40 degrees, or 19 newtons. The y component, 25 newtons times the sine of 40 degrees, or 16 newtons. The second vector, we have 15 newtons times the cosine of 120 degrees, which gives us negative 7.5 newtons. And we have the y component, 15 newtons times the sine of 120 degrees, which gives us plus 13 newtons. Now, I'm going to draw a slightly different diagram in this one, equivalent to anything that we've done before. First of all, in black here, I've got the first vector, and then the second vector head to tail with the first. Okay? So it's like I've taken the second vector here and moved it over here to find where the resultant ought to be. Now here's the resultant in blue. Okay? So we can always do that with two vectors. Start it with the tail of the first and go to the head of the first, and put the tail of the second there and go to the head of the second. Okay, now we've found for the first vector that the x component is 19 newtons, which means we come over here 19 newtons. Then we can go up 16 newtons, that's the y component of the first vector, and we get to the tip of the first vector. And from there we can go up 13 newtons, which is the y component of the second vector, and over negative 7.5 newtons, which is the x component of the second vector, and that gets us to the tip of the second vector, and that's where the resultant ends. Now, where are we going to be? What are the components of this resultant? Well, in the x direction, we came over 19 and back 7.5, and those distances represent newtons. And that gives us a net of 11.5 newtons. 19 newtons and negative 7.5 newtons gives us 11.5 newtons here. So that's going to be the x component of the resultant. If we go up 16 newtons here and then up 13 newtons, we go up a total of 29 newtons, and that's the y component of the vector. Now, having found the x and the y components, we just go through the usual analysis. Okay, here we write it out again. The x component is 19 newtons and negative 7.5, or 11.5 newtons. The y component is 16 newtons and 13 newtons, or 25 newtons. The magnitude of the resultant we get by adding the squares of the components and taking the square root, 31 newtons. You can plug these numbers in and you'll find that the result is close to 31 newtons. And the angle is the inverse tangent of the 29 newtons over the 11.5 newtons, and that's 68 degrees. So that the resultant, the net force that we get from a force of 25 newtons at 40 degrees and 15 newtons at 120 degrees is a force of 31 newtons at an angle of 68 degrees.